if you know where you're going to college, this will probably not be super helpful. If you don't know where you're going to college, they have a lot of good information about local colleges. So, video will get posted in 5th period. Bye. Head straight to the gym. Gym. That way, guys. Gym. Head to the gym. That way, then that way. Gym. This way. All the way to the wall, then to the left.
I might go to Purdue.
How are they seniors and not know where the dang gym is? How are they seniors and not know where the gym is? All of them heading the wrong way. All right. So what we're going to do with this is I'm going to give you equations that look like this. And we are asked to find the center of the circle. So we're going to find the center of the circle.
Oh no, I should have taken notes.
And I said it instead of repeatedly.
Can I take the notes from yesterday?
PDF of them are posted up on Canvas already.
Let me do that.
What's up? We will. First thing I'm going to do is I'm going to break these up into my X's and Y's. But absolutely you can do it that order first. So I'm going to put my X pieces together and my, Y pieces together. So I'm just going to rearrange things because it doesn't matter what order we add and subtract things in. So I'm going to have my 3x squared minus 12x. And we're going to have our plus 3y squared plus 18y. And that all equals 0. And we would really like to not have that number in front of our x squared or our y squared. And since they match, we can do it where we just divide everything by 3. That's valid. I'm going to do it the other way where we pull them out of each set individually. So I'm going to put these into groups like this, grouping my x's together, grouping my y's together. Oops. Helps if my screen goes. There we go. I'm grouping it like this because I want to look just at my x's. I see in my x's that 3x squared minus 12x. I could absolutely pull a 3 out of there. 3 times. This would give me x squared minus 4x. Right? What's up? Can't hear you. Because I'm not actually trying to factor it. I'm trying to make it be something I could complete the square on. I need to have a perfect square so that it's a circle formula. Because I'm trying to make it look like my x minus h squared plus y minus k squared equals my r squared. That's what I'm trying to get it to look like. So that means I need to have perfect squares over there. And I'm going to need all my constants to be on the other side. So again, on my y's, I want to take out this 3. So we're going to take out a 3 that's in front of my y squared. Again, not trying to factor it, just trying to make it be something we could complete the square. That's going to leave us with our y squared plus 6y. And leave myself a little space here, equals 0. And again, you could divide both sides by 3, but I'm doing it this way because I want to show you something for when those numbers don't match. So if I look, and I'm going to change the view real quick. here. What would we need to add here in order to make this be a perfect square? Because it's that middle term, my -4 divided by 2 squared. So if I add 4 right here, that makes this a perfect square. But when I look at my whole equation, if this is 3 times this trinomial now, did I add 4 to this side? How many did we add to this side? 12. 4 times 3. So whatever I do to the left, I have to do to the right. So I need to add, oops, sorry, depends. 4 times that blue 3 that we factored out in front. I added 4 inside the trinomial, but there's that 3 multiplied out front. Whatever I add to the left, I had to add to the right. So this is how we do it if those numbers don't match. You can absolutely, since this one does match, we could do that. So let's do the same thing for our y's. What would we need to add here to make this be a perfect square? 9. 6 divided by 2, which gives me 3. 3 squared gives me 9. So since I added 9 inside that trinomial, what do we need to add to the right-hand side? 9 times 3. Which is 27, because I know some of us did that. That's totally fine. I'm just writing it out like this so that we can see where those pieces are coming from. 9 times that purple 3. And I know my blue and purple kind of look very similar. Sorry. I'm just going to make this purple. Oh. Be a little bit darker. I'm just making the purples be a little bit darker so they're easier to see. Those now look black. In between. Okay. Does everyone see what we did, even if we're not entirely sure why we did? There we go. Now the blues look different than the purples that look different from the blacks. Good. That's what I was aiming for. So the reason we do this is so that I can write these as perfect squares. So this has that 3 out front. And we're going to have what as my factor here? X minus 2 quantity squared. And we have our 3 times what? Y plus 3 squared equals, 12 plus 27, 39. Okay, so I know I wrote some kind of in-between steps there on some stuff. We could get our center here, but since we also need radius, I still need this to match. So I need my coefficients to leave. So what are we going to do to get my coefficients to leave? Divide by 3. If I divide this by 3 and divide this by 3 and divide this by 3, I can absolutely do that. I know some of us spotted that we could divide by 3 at the beginning. That is absolutely valid. Just if those two don't match, we need to make sure we know what we're doing. So we're going to wind up with our circle's equation being x minus 2 squared plus y plus 3 squared equals what? 13. So what is my center for this circle? Yes. H comma K. 2 comma negative 3. That's why we have completing the square for this. It has to be in that perfect square form. What is our radius? 13 is our radius squared. So what's my radius? Square root of 13. Okay. questions on this one? We're going to do another one very much like it. So we're going to find the center and radius of a circle with this equation. Almost the same thing. I've got 2x squared plus 2y squared minus 12x plus 4y minus 15. Lots of pieces. Yes, Jim. Yeah. All right, so get your x's and your y's together. So the first thing we need to do is get our x's and y's together. So I'm going to take and write this as my 2x squared minus 12x. And we're going to add our 2y squared plus 4y. And you can either leave your minus 15 on this side, or we can take it to the other side. You want to take it to the other side? Go ahead, let's do it right now. Add 15 to both sides.
That's just better.
It gets it out of the way and just in its own little space.
Yeah,
Adding 15 and getting him out of the way. So then we're going to look at our x's individually and our y's individually. I can factor a 2 out of those x's. And that's going to leave me with x squared minus 6x. And I'm going to leave myself a little space here. On the next pair, on my y's, what can we take out of both of them? 2. Do not take y out. We're not factoring. We're just getting rid of that coefficient. Y squared plus 2y. Leave a little space, and it's going to equal 15. What needs to go here to make this a perfect square? Plus 9. What are we subtracting from the other side? Or we're adding to this side, excuse me. Adding 18.
So
we added 9.
9.
We added 2 times 9.
And then 2 times 1.
And then what's going to go in here for my y's? 1. We take our middle term, divide by 2. We have 1 times 2. What's going to come over here? Plus 2. We always add it to, or like that last term. Because it's always going to be a perfect square, yes, it will always be positive. Because we're trying to make this be that perfect square trinomial. What's up? Yeah, give me a second. So now we're going to write these in their perfect square forms. I sure know you know how to do that. I've seen it. All right. So our x's, I'm going to have my 2 times, what is our factor here? X minus 3 squared. It's always going to be half of b. Every time. Whatever your b term is, it's half of that. Plus what? What are we talking about?
Oh, I'm sorry.
I love how I said what and she instantly goes, y. What? What's our y term? Plus 1. Quantity squared. And it equals what?
35.
I have heard many options, all very close together. Think it through slowly.
35.
Thank you.
35.
I heard 36, 34, and then 35. Slow down. Don't make the adding be the thing that takes you out.
36.
We can complete the square. Don't get messed up on the adding.
I know this is
So, last step to get this to be a circle. What do I need to do to get rid of these numbers in front?
2.
Divide by 2.
So you have 35 over 2.
So, that is why I don't necessarily recommend starting with dividing everything. You're going to wind up with fractions on the right-hand side in particular. But if you like it, go for it. You can do fractions. X minus 3 squared plus y plus 1 squared equals 35 halves.
Why do I learn this in geometry or finding this in way easier?
Honestly, you didn't often get given multiplied out circles all that much in geometry. Not fully multiplied out like this. Because not everyone is super comfortable with completing the square. But just saying, as college level pre-cal kids, you are expected to be able to complete the square. It comes back in lots of courses, especially in higher mathematics. So you will use completing the square. So what is our center?
3 negative 1.
Center is 3 negative 1.
Well, I think this first.
What is our radius?
Square root of 32 over 2.
Yep, square root of 35 over 2. However, do we have a square root in the denominator? Oh my gosh, we always have to rationalize our answers. What's up?
Why can't we just make it 17.5?
You could, but if we're trying to simplify or rationalize, we need to be able to actually do that. And you could do it as a decimal in there, but if then we were trying to estimate a value for square root of 17.5, that's a lot harder to do. So it's not wrong. It's not wrong.
Oh, that's okay. We can have a decimal number.
It's not wrong. It's not pretty. It's not nice. And if you need to do anything else with it, it would be hard to work with. So what would we do to rationalize this? Times by square root of 2 over square root of 2. So rationalized, what are we going to have in our numerator? What is 35 times 2?
7.
Rationalizing, multiply. We multiply this guy by square root of 2 over square root of 2 to get the radical out of our denominator. 35 times 2 gives us 70 over 2. Square root of 70 over 2.
Oh.
And always a good idea to think through if it has any perfect squares as factors. Is 70 divisible by 4? Is 70 dividable by 9? Is 70 dividable by 16? 70 dividable by 25? At that point, I can spot that 25 times 3 is going to be more than 70 anyway, so we're not going to have to go up any higher for perfect squares. So just think through your first 4 or 5. That's usually plenty. Usually plenty if we're trying to simplify a radical. Yeah, I was like, we can't forget how to rationalize. Literally every test has in the instructions you have to rationalize your denominators. Every test, every quiz, have to rationalize. Not optional.
Those line things.
Okay? Do not leave radicals in denominators.
Maybe change the
To be fair, those ones have been, that one has been pretty much set since, want to go with Archimedes? It's been a minute. It's been a
Well,
minute.
we're at least a new generation.
Unfortunately, you will never change the old, mostly white guys' minds.
Let's make a time machine to go like kill them as a baby.
We're not going to make a time machine and go beat up Archimedes.
Seriously?
Yeah.
All right. So we're going to practice writing some equations. This is kind of working the other direction. And I guarantee you, we overthink these. Especially this first one. We're going to write this in our circle equation. So we've been working with our x minus h squared plus y minus k squared equals our r squared. So for this first piece here, what's our h? 2. What's our k? -3. What's our r? 5. Substitute them in.
I'm doing this right actually. More work.
I'm the judge.
So we're going to have our x minus our h, so x minus 2 quantity squared plus our y minus k, our k being -3, this is going to become y plus 3.
I'm doing that.
Yup.
Oh, I started.
Equals 25. 5 squared. Ta-da! That's it for that one.
Please put this in place.
I was like, there's something I get on the homework.
Homework is on my friend.
Evan, I don't care about the distance formula.
Well, you're going
Ooh, why are we talking about the distance formula?
to find the radius.
To find the radius on the next one!
Where do you
I'm gonna crash out.
I've got a center and I know where it hits. So I know if I look at this circle, we've got a center at -2, 1, and it goes through the point 3, 4. I need to know my radius, which means I need the distance between them. Oh, snap.
No.
It's like square root of x.
One is
So our distance formula, just so that we remember, that's our square root of the difference in our x's. So we do our like x2 minus x1 squared plus the difference in our y's. y2 minus y1 squared. So our distance here is the square root of, and we're going to substitute those in. So my x2, I'm going to have that be my 4 minus, oh, sorry, 3. Let's do my x's first. 3 minus -2, so that becomes plus 2 squared. And the y's, that's my 4 minus 1 squared. So what is 3 plus 2 squared? 4 minus 1 squared. So my distance is what?
34.
Stop letting the adding throw you off, y'all. Slow down on the adding. So what's our radius? What's the radius? Square root of 34. This is my R. The distance between my center and the edge is my R.
That's your radius.
So when we're writing this as an equation, what is my H? -2, that's my H. What's my K? 1. What's my R? There we go. The square root of 34. Into the equation.
Oh, I think that's what they meant. Like they meant +2 for the equation.
Yeah, entirely possible. So x minus h, so x minus -2, we get x plus 2 squared And we have our y minus k. So y minus 1 squared. What does our equation equal? 34. It's our radius squared. Our radius is square root of 34. So in our equation, we have a 34. Okay, we're going to do a couple more like this that are a little bit weird. And then we'll get to our last piece of this chapter, or this section.
Oh my gosh, this is like running.
What? Tangent.
Tangent?
That
What?
in 4 years.
What?
Darwin would be proud.
So let's think about what that means. If we have a center at negative 3, 6, and it's tangent to the y-axis. So if I have like a little graph, negative 3, 6 is somewhere up here, right? What does it mean to be tangent to something?
The shortest distance.
The shortest distance, right? It's going to brush up against it. So my circle means it's like that. It touches it. It hits it. So this is going to be my radius.
Oh.
Also the distance. You're not wrong. It's a distance. How can I find that radius?
Guess.
It's like 3.
How do we get that? Yeah. This is the point 0, 6, right? Because it's straight over. My x is now 0 and the y is 6 here. It's straight across. That is as close as it can possibly be. If this is the point negative 3, 6, what is the distance between them? R. More specific. We went 3 steps to the left, but can distances be negative? No, so my radius is going to be 3.
That's your answer.
Yeah, you can do the full distance formula if you want to. I mean, that's not the whole answer. That's not the equation. But that gives me the radius. You can do the full distance formula. You will still wind up at 3. So when it's tangent to something, we have a lot of information right there, even just in the word tangent. Okay, so tangent just means it goes up against it. So writing our equation for this, what are we going to have? X plus 3 squared. And what's next? Y minus 6 squared equals what's our radius? Our radius is 3, but what the equation equals is 9. 3 squared. It's always our radius squared. All right. Yes. Side conversations need to cease. So when it gives us less information, we get a little scared, but they actually gave us plenty. Same thing with this next one. This one says it's tangent to both axes. The center is in quadrant 2, and it has a radius of 4. So where is quadrant 2 if I'm looking at a graph? Top left. Remember, this is quadrant 1. This is quadrant 2. So we know it's going to be tangent to both axes. So my circle is going to look kind of like this. I'm so good at drawing circles. And we know it has a radius of 4. So I know that this has a radius of 4 and this has a radius of 4. The center's what?
4.
What? Watch your signs.
Negative 4.
Negative 4, 4. Distances are always positive, so make sure if we are in a certain quadrant that you wind up with the correct values being negative. So my center is at the point -4, because we're in quadrant 2, my x's are negative, +4, my y's are positive. So this is my center. So our equation is what? X plus 4 squared, y minus 4 squared equals 16. Okay? So they're going to pull in all kinds of things. They will pull in the textbook, they'll pull in midpoint formula on stuff, they'll pull in our distance formula on stuff. So you're going to see all kinds of things that we've all talked about before. But we have one more piece in this section that we need to talk about. And that's semicircles. I'll put it back. I heard an oh wait. Oh, sorry. There we go.
Just get the area of the circle divided by 2.
That would be if we're looking for the area. We're looking for the equation. Okay. So we have a few different kinds of semicircles. So remember, semicircle meaning half circle. So I could take my circle and divide it into semicircles by taking the top half and the bottom half. Those are two semicircles that make up a circle. So to get top and bottom semicircles, we are going to solve for y. So we'll go for a y equals. If we want the top one, like the green, that will be called our upper semicircle. And we're going to wind up with a, like y equals a positive square root statement, because we need to get all the way down to a y equals. And if we're looking for our lower semicircle, we're again solving for y, but we're going to use a negative square root statement. So when we square root both sides, we often will put plus or minus, but since we're doing semicircles, we need to make a choice. Upper we use positive, lower we use negative. When we're looking for left and right semicircles, very, very similar, but instead of solving for y, we're going to solve for x. So again, I can divide my circle into two different semicircles. I could have a semicircle over here or a semicircle over here. It still makes one circle. I'm just cutting it a different way. And again, very, very similarly, for my left semicircle, we're going to wind up with an x equals and a negative square root statement. And for my right semicircles, we're going to have a x equals and a positive square root statement. And I promise when we play with the equations, it makes a little bit more sense. So I'm going to give us an equation, and we're going to find equations for different semicircles. So upper and lower, we solve for y. Left and right, we solve for x. What's up?
West end of square root on the other side.
We will see that in just a second. We're going to wind up with, like, we're taking our equation that I gave us, like our x plus 3 squared, y minus 2 squared, and solving that to get a y equals. So it's just whether or not we choose our positive or negative when we square root both sides, because we don't need to put plus or minus. So let's look at this one. I've got x squared plus y squared equals 81. And we're going to find the equation for both our upper and lower semicircles. Since we are going for upper and lower, that means we are going to solve these for y. Upper and lower means solve for y. So looking at our equation here, what do I need to do to solve this for y? Subtract x squared. So we have our y squared equals 81 minus x squared. Or you can put negative x squared plus 81. Either way is fine. Totally cool. Still need to get y by itself. Square root both sides. So y equals, and normally when we square root both sides, we put plus or minus, right?
Oh, that's how you vote.
Square root of 81 minus x squared. That's kind of our general formula for the semicircle. So what is the specifically our upper semicircle? Y equals the positive square root, which you can put the plus or you don't have to, because if we do not write anything there, it's assumed to be positive. 81 minus x squared. What is the equation for my lower semicircle? Y equals negative square root of 81 minus x squared. And that's all we need to do with them. We're just writing them as the equations.
If this pops up on the quiz, do you want to, can you just put plus or minus and actually answer, or you want us to separate it?
If I specifically ask you for upper and lower semicircles, you got to tell me which one's which.
Okay.
Or if I, again, specifically ask you for find me the equations for left and right semicircles, I need to know which one's which. So label them. Okay? Let's do one more of these. We're going to find the equations for left and right semicircles, and this one has a different center, so it's a little bit more. We can still do this. So since I'm looking for left and right, which variable are we solving for? X. So solve for x since we're looking for left or right. So what are we going to do first? Subtract the whole y chunk. Subtract y minus 5 squared from both sides. We don't have to multiply it out. In fact, I'd rather you didn't. So that's going to leave me with my x minus 3 squared equals 4 minus y minus 5 squared. That's cool. Still trying to get x by itself. Square root both sides. I need to get rid of the square on the side with the x. When we square root both sides, we wind up with our x minus 3, and we're kind of starting out with our general form here. So I'm going to put my plus or minus square root of all that gobbledygook. 4 minus y minus 5 squared. What's up? Ooh, say it louder. Because since there is subtraction under here, we cannot simplify it without multiplying everything out, refactoring, and then doing it. We can only simplify our radical if everything's being multiplied. So we can't pull that 4 out to be a 2. We would have to multiply everything back out and make it a perfect square. All right. I still need to get my x by itself. What do we need to do? Add 3. So our kind of general form is going to be, I'm going to put the 3 in the front because I don't like whole numbers behind my radical. So I can have my 3 plus or minus square root of 4 minus y minus 5 squared. Which is my left semicircle? X equals 3 minus square root of 4 minus y minus 5 squared. What's my right semicircle? Everything else is the same, but it's going to be the 3 plus my square root of 4 minus y minus 5. Okay? That is the end of section 3.2. Okay? Our next quiz is next Thursday. And I believe it's over sections 3.1 and 3.2 and 3.3. So what we do next as well. Okay? So you have the whole, we're going to do the homework. This homework is due on Monday.